Session 8.1 The Essential Ingredients of Hypothesis Testing. For this session, we're gonna learn how to write a null and alternate hypothesis for tests involving a population proportion. For next sessions, we're gonna talk about how to do the hypothesis testing involve a population mean. And also, we're gonna learn how to compute and interpret a test statistic and p-value. Hypothesis testing, a procedure that enables us to choose between two claims when we have variability in our measurement. We do have a 4-step for hypothesis testing. First one, hypothesize. State a hypothesis that will be weighed against a neutral skeptical claim. Number 2, prepare. Determine how you will use the data to make your decision and make sure you have enough data to minimize the probability of making mistakes. So for the number 2, we kind of perform the experiment. Number 3, compute and compare. We're going to collect the data from the step 2 and compare them to your expectation. Number 4, interpret. State your conclusion. Do you believe the claim or do you find the claim doesn't have enough evidence to back it up? So we do have 4 steps. Let me use the example to explain this 4 steps. A coin is spun on a flat surface. You hypothesize it is more likely to come up heads because that side of the coin but goes out slightly compared to the tail size. So this is the first one. We're gonna state the hypothesis because when we flip the coin, we're supposed to have a 50% chance to get the head, 50% chance to get the tail, and this is called the natural hypothesis. But for this experiment, since the coin is spun, so the coin is more likely to come up the heads. So this is gonna be the first part here. We're gonna state the claim either more likely to come up the heads or the coin is going to be fair. You spin the coin 20 times and it comes up heads all 20 times. If it was equally likely that the coin stopped on head or tails after spinning, it would be very unusual to find 20 heads in 20 spins of a coin. So this is going to be the number 2, prepare. We're going to perform the experiment. We decide that you would use the proportion of heads in 20 spins of the coins to test your hypothesis. This time, we're going to flip the coins like 20 times. If we roughly to get 50% head, 50% of tails, that means the coins is fair. Okay? After that, we collect the data. We find it out 20 spins result in 20 heads. We know that this is very unusual. And then we use this data to compare to our expectation. Okay, if this is a fair coin, we would expect 50% of the head, 50% of the tails. However, we just got the result 20 heads, which is much greater than what you expect. So after that, we're gonna be the number 4, interpret. We're gonna state the conclusion. This is so unusual that you would conclude that your hypothesis that the coin is more likely to come up heads when spinning is correct. Since it is unlikely to get 20 heads in 20 spins, so we conclude that the coin is more likely to land on the heads when spun. Okay, now we're gonna introduce more details about the hypothesis testing. Hypothesis. Hypothesis is a claim or statement about a property of a population. And hypothesis test is a procedure for testing a claim about a property of a population. For the first step, we're going to state the hypothesis. We're going to state the claim. And then we have 2 hypotheses. First one called null hypothesis. Null hypothesis is a statement about the value of a population parameter that contains equality to some claim value. So it has to be contain equal sign in the null hypothesis. Second one, we call that alternate hypothesis. Alternate hypothesis, we always use the H1 or HA or H capital letter of A. This is a statement about the value of the population parameter that is true when the null hypothesis is false. So I want you guys to remember that the null hypothesis, we use H0. Alternate hypothesis, that will be either using H1, HA, okay? For my case, I usually use H1 for the alternate hypothesis. For the alternate hypothesis, we always use not equal, strictly greater than, or strictly less than. H0 and H1 are complementary. What does that mean? Let me explain to you guys. Okay, we have the null hypothesis. We have the H0 and we do have an alternate hypothesis, H1. What does that mean? H0 and H1 are complementary. Actually, for the null hypothesis, we do have less than or equal to, greater than or equal to, or equal sign in here. Okay, so alternate hypothesis, this is gonna be a pair. When you have a less than or equal to, your alternate hypothesis is gonna be using strictly greater than. So on the number line, you could see null and alternate hypothesis is gonna be the complementary. It's gonna be take everything. When you have a null hypothesis is greater than or equal to, then you will have strictly less than. And when the null hypothesis is equal to, that means alternate hypothesis is going to be not equal to. So these three guys is always a pair. And this is what they say. Null and alternate hypothesis is always complementary. Okay, but we usually, for the null hypothesis, most of the statistic book, they don't want to use this one anymore. They will replace it for the equal sign. Okay, the equality. Okay, instead of using this guy, we will be using equality. So the null hypothesis is always using equal. Alternate hypothesis, it can be greater than, strictly less than, or not equal to. So this is depends on your questions in here. Okay, and then you're gonna say, null hypothesis is a statement about the value of a population parameter. Okay, population parameter that contains equality to some claimed value. So for example, for these sessions, we are working on population proportion. Okay, remember population proportion? We use the P for the notation. Population proportions. Okay, so for example, we have a null hypothesis and alternate hypothesis. We are working on the null hypothesis. The population proportion has to be equal to a some value. Okay, alternate hypothesis, you do have this three choice: greater than, less than, or not equal to. So maybe, for example, depends on your question, I could use the greater than. Okay, so this is gonna be our first step here. Okay, state the claim. Keep in mind that for the null hypothesis, the H0 here, some statistic book will be using this one, less than or equal to, greater than or equal to, or equal. Okay, it always including equality. Alternate hypothesis, it's going to be strictly greater than, strictly less than, or not equal to. Most of the time we'll be using equal instead of using these three guys for the null hypothesis. Okay, let's go back to our PowerPoint. Hypotheses are always about population parameter. They are never about the sample statistic. So I want you guys to keep in mind this one, that we always use population parameter. We never using the sample statistic. So you don't put the sample notation. We never use the sample statistic. Okay, it has to be the population parameter. Okay, using the P, or later on we're gonna talk about the population mean. We're gonna using the population mean. Population mean. We don't use the sample statistic. Okay, don't use that one. The null hypothesis is always gets the benefit of the doubt throughout the hypothesis testing procedure. We only reject the null hypothesis if the observed outcome is extremely unusual, if the null hypothesis were true. So after we get the data, we're going to draw the conclusion. We're going to say reject the null hypothesis or fail to reject the null hypothesis. Okay, we only talk about that one. We don't say accept the null hypothesis or accept the alternate hypothesis. So keep in mind, reject and fail to reject. Okay, let's talk about the alternate hypothesis. We do have 3 types of alternate hypothesis. First one, a left tail alternate hypothesis states that the parameter is less than the value specified by the null hypothesis. For the example, okay, this is the alternate hypothesis. We are working on population proportion. First one, we do have a strictly less than. Okay, strictly less than in number. When we have a strictly less than, we call this is the left tail test. Okay, this is the left tail test. Second one, that will be the right tail test. The alternate hypothesis population proportion is strictly greater than a number. Okay, greater than, then this is the right tail test. Another one, alternate hypothesis population proportion is not equal to a number. When you have not equal to, that would be the two-tailed test. Okay, I need you guys write it down. This is very important. When you have a strictly less than, that will be left tail. Strictly greater than, that will be right tail. Not equal to, that will be two-tailed test. Okay, let's try to do the example. 2014, we found that 61% of Americans believe in global warming. A researcher believes this rate has declined. State the null and alternate hypothesis in words and in symbols. Okay, so you could see we are working on population proportion, right? This is talking about the proportion in here. And then I want you guys to state the null and alternate hypothesis. So the null hypothesis, and we know we are working on population proportion. So that would be P, right? And remember I say null hypothesis is always equal. So we will have first one, H0 population proportion equal 0.61. This is the null hypothesis. And then stay in words, the same proportion of Americans believe in global warming as in the past. Okay, alternate hypothesis. So alternate hypothesis, you do have 3 types, either strictly less than, strictly greater than, or not equal to. For this one, you're going to look at the claim statement. A researcher believes this weight has declined. Okay, it's declined. So that will be strictly less than. And then, why in the words, the proportion of Americans who believe in global warming has decreased. Okay, so it's going to be strictly less than. And then for this one, it should be left tail test, right tail test, or two tail test. Strictly less than, that will be left tail test. Okay, write it down, left tail test. So this is the first part. You need to know how to state the null and alternate hypothesis. And then keep in mind, for these sessions, we're working on population proportion. So that's why we do have the P here. Later on, we'll be working on the population mean. Remember what's the notation for the population mean? you're gonna put it in here. Alternate hypothesis, it really depends on your claim statement, just like here. Decline, okay? If the daylight is increasing, then that'll be greater than, okay? Or they may say they believe this weight is different, okay? So it's gonna be not equal to. Okay, example 2. I want you guys try to do it by yourself. Okay, let's check the work. In 2016, a Harris poll estimated that 3.3% of American adults are vegetarian. And nutritionists think this weight has increased and will take a random sample of American adults and record whether or not they are vegetarian. State the no and alternate hypothesis in words and in symbols. Okay, so again, they are working on the population proportion. And then the no hypothesis is always using equal. So we do have a p equal to 0.033. They stated a percentage, but try to put it in decimal, okay? So divided by 100, so that will be 0.033 here. And then alternate hypothesis. You do have either strictly less than, strictly greater than, or not equal to. So look at the statement here. A nutritionist thinks this weight has increased. Okay, increased. So that will be strictly greater than. Okay, I'm sorry, I forgot stay in the words in here. Okay, strictly greater than because has increased. And then stay in the word. So proportion of Americans adults who are vegetarians is greater than 0.033. Okay, write it down. It will be left tail, white tail, or two tail. That will be white tail, right? Because it's greater than. In the exam, I only need you guys state the no and alternate hypothesis in symbols. I only need these two guys. You don't have to write it in words, okay? Okay, now let's talk about the significance level. Okay, significance level we will be using alpha. Significance level is the probability of making the mistake of rejecting the no hypothesis when in fact the no hypothesis is true. So look at this picture. What is a significance level? Significance level at the alpha, when you have the left tail test, this part of the area will be your alpha, significance level. If you're working on the white tail test, the area of the white tail here will be your significance level. If you're working on the two tail test, then the area of this two tail will be the alpha. So meaning that when you have the two tail test, you have to divide it by 2 here. For this case, significance level is always given. Okay, so you do have a 0.05, 0.01, or 0.10. This is usually we use in this case. So for example, if I given significance level is 0.05, talking about on the left tail here, the area of the left tail will be equal to 0.05. The area of the white tail here will be 0.05. And since this is a two tail, so you're gonna be divided by 2. So 0.05 divided by 2. So each area of the tail will be 0.025. Okay, 0.025 for each area here. Test statistic is a value used in making a decision about the null hypothesis and is found by converting the sample statistic to a score with the assumptions that the null hypothesis is true. So what is a test statistic? When we're working on a claim about a proportion, we do have this formula to calculate the test statistic. For example, we have the null hypothesis population proportion equal to 61%. For the alternate hypothesis, population proportion will be strictly less than 61%. From the alternate hypothesis, we know this is going to be the left tail. So my picture is going to be looks like this, right? Left tail. And the area of the left tail, that will be equal to your significance level. And remember, significance level is always given in this case. For example, significance level is equal to 0.05. That means the area of this left tail will be equal to 0.05. So we do have a null and alternate hypothesis in here. Either one of them will be true. So for your null hypothesis, we're going to put it like here. Okay, this part will represent your null hypothesis. And your alternate hypothesis will be on this left tail here. So when we collect all the data from your experiment, we're going to put into this formula. And we're going to calculate the test statistic. If your test statistic is falling on the left tail here, then we're going to say reject the null hypothesis. Then we believe the alternate hypothesis is true. Okay, if the test statistic is located here, that means we're going to reject this guy. So we believe alternate hypothesis is true. But if your test statistic is located here, then we're going to say fail to reject. Okay, then we believe that null hypothesis is true. So that is the idea of the hypothesis testing. First, we're going to state the claim. And then for the alternate hypothesis, we decide it's going to be left tail, right tail, or two tail. And if this is the left tail test, the area of the left tail will be equal to your significance level. Then we're going to prepare the experiment, collect the data, and use the formula to find the test statistic. If your test statistic located in the left tail here, that means we're going to reject the null hypothesis. And this is going to be true. But if your test statistic located in here, we're going to say fail to reject the null hypothesis. And then we believe the null hypothesis is true. Okay? And then we're going to draw the conclusion. This is the idea of hypothesis testing. But how can we compare with the value of the z and the significance level? Since the z is the z-score, this is what we learned from the session 6.2. But the alpha, the significance level, that will be the area. We can't just compare the z-score with the area here. So what we're going to do? Let's talk about this part later. Okay, now we're going to talk about the test statistic. The test statistic has the structure. We're going to use the observed value minus the null value and then divided by the standard error. So this is the formula for the test statistic for the proportion. We have the sample proportion minus the P0. What is the P0? P0, that will be from your null hypothesis. Okay, just like here. Your null hypothesis P equal to 0.61. Okay. So when you have this formula, you're gonna plug in the P0 will be the 0.61. And then the P hat, this is the sample proportion. You're gonna look at your question. Usually they will be given. And then how can you calculate the standard error? Standard error, that will be your P0 times 1 minus P0 divided by the N. N is going to be the sample size. Okay, so this is the formula for the test statistic of the population proportion. Let's do this example together. In 2001, the poll reported that 12% of Americans were cool skeptics, who reported worrying a little or not at all about global warming. In 2014, 25% of those responding to the poll classified themselves as cool skeptics. Assume that the sample size for 2014 poll was 500. Can we conclude that the percentage of Americans who identified themselves as cool skeptics has increased since 2001? So you could see these questions we are working on the population proportion. Now, we want to calculate the test statistic. First, I want you guys try to do it by yourself. State the null hypothesis, alternate hypothesis. Tell me this is going to be left tail test, right tail test, or two tail test. So the null hypothesis will be P equal to 0.12. And then alternate hypothesis, we're going to look at here. Can we conclude that the percentage of Americans who identified themselves as cool skeptics has increased? Okay, it's increased. So it's going to be P strictly greater than 0.12. Okay, left tail, right tail, two tail. This is going to be white tail test because it's strictly greater than, okay? Write it down, white tail test. Okay, now we're going to look at the formula, the test statistic formula. Try to fill it in. What is your P hat? Which one is going to be your sample proportion? What you going to put for the P naught here? And then what is your N? What is your sample size? Plug it in first. Okay, so since they say assume that the sample size for the 2014 poll was 500. Okay, so you know in the 2014, the 25% here, this is going to be the sample proportion. So the sample proportion will be equal to 0.25. And then the P naught here, we always use the null hypothesis, which is going to be 0.12. And then the N, sample size, that will be 500. Plug it in. Okay, use your calculator. When you're using the calculator, you could put everything into your calculator. Okay, you don't need to separate it. But make sure you're going to put the preference here. Okay, I'm going to show you guys after this how to use your calculator. You should get 8.95. So this is talking about the observed value of the test statistic is going to be 8.95. This means that while the null hypothesis claims a proportion of 0.12, the observed proportion was much higher. 8.95 is really high. Standard error higher than what the null hypothesis is claimed. Okay, I really need you guys know how to state the null and alternate hypothesis. Write it down, left tail test, right tail test, or two tail test. And then apply this formula for the proportion to find the test statistic. Okay, let me show you guys how to use the calculator to input this one. Okay, so what you're gonna put, make sure you put the preference. Preference 0.25. Preference 0.25 minus 0.12, cos preference, divided by, so you're going to divide it by the whole things here. So I'm going to use the second here, get the square root, and 0.12 times 1 minus 0.12, and then divided by 500. Make sure you have the cos preference. And so it's gonna be 8.95 here. Okay, make sure it's the whole thing here divided by the square root, and then inside the square root it will be including the 500 as well. So you could see I do have the parenthesis for the 500 here also. Okay. Okay, p-value. Let's go back to the p-value. Okay, p-value, probability of getting a sample more extreme than the ones observed in your data, assuming H0 is true. Let's look at the left tail example. So this is our test statistic. Okay, test statistic will be the z-score. We'll be using the z-score to find the area of this region. And we call this is gonna be the p-value. And then we're gonna use the p-value to compare with your significance level. Remember, this part here, we're talking about the alpha will be the area of the left tail. And then the test statistic will be the z-score here. And we want to compare with these two guys. Okay, so we call this is gonna be your p-value method. We use the test statistic, the z-score here, finding the area of this region. And we call this is gonna be the p-value. And then we're gonna use the p-value to compare with your significance level. So look at this picture here. Originally, this is gonna be equal to alpha, right? Alpha will be the area of this left tail. And then when we're finding the z-score, we'll be using the z-score to find the p-value. P-value will be the area of this tail. Okay, so area compared with the area, it will be make more sense, right? One more time. Using the z-score to find the area of this tail. And this is gonna be your p-value. And then we use the p-value to compare with your significance level. If the p-value is less than or equal to the alpha, then we reject the null hypothesis. That means your test statistic is going to be located in this part. If your test statistic is located here, we use your test statistic to find the area of your p-value. Okay, and this time p-value will be greater than the significance level. So we're gonna say fail to reject the null hypothesis because your test statistic is located in this part. And this part is represent your null hypothesis. Does it make sense to you guys here? I need you guys to highlight this part here. Make sure you remember p-value less than or equal to the alpha, we're gonna reject. If your p-value is strictly greater than the alpha, then fail to reject. Okay? Okay, let's look at this example. The p-fit example, we already find the test statistic is going to be equal to 8.95. And then I used a StatCrunch here. We get this picture. Okay, this is a normal distribution. The z-score will present your test statistic, 8.95. So you're going to know the 8.95 is somewhere like here. So since the 8.95 is really far away from the normal distribution here, we could assume that the area of the p-value will be equal to 0. And this p-value gives us strong evidence to reject the null hypothesis. So the picture is going to be looks like here. If your z is located somewhere like here, the p-value is almost equal to the 0. And you know that the test statistic is going to be lying on the tail. So you know that will be reject the null hypothesis. Okay, we're going to reject the null hypothesis. So this p-value gives us strong evidence to reject the null hypothesis. And we conclude that the percentage of Americans who identify themselves as cool skeptics has increased since 2001. Okay, we will have a more example on the session 8.2 to perform hypothesis testing for population proportion. Okay, for these sessions, I just introduced the concept of hypothesis testing. That's it.